good evening. Welcome to this video section. My name is Samuel Dominic Chukwu Emeka, aka Sam Dom for Peace. In this video session, we shall discuss partial fractions. Partial fractions is a topic that you probably might skip it in algebra. It's actually under algebra, but some people skip it in algebra. But for engineering majors or mathematics majors, those of them that will do calculus 2, they do integrate. One of the methods of integration is integration by partial fractions. So they come back to it. Okay, when you do calculus 2, if you're going to take calculus 2 in the US, one of the topics they teach is integration by partial fractions. So in calculus 1, you learn integration by parts. We've done integration by parts. But in calculus 2, you learn integration by partial fractions. So it is important. In Nigeria, those of you in high school that are taking further mathematics, you do partial fractions. Okay, those of you in high school taking further mathematics. And of course, if you are in Nigeria in college and you're engineering major, mathematics major, physics major, you still do integration. And one of the methods of integration is integration by partial fractions. Yeah. Actually, they used to ask it in JAM in Nigeria, but recently I think I checked and they don't ask it anymore in JAM. But if you're in high school and you're taking further mathematics, you get to do partial fractions. And for engineering majors, physics majors, mathematics majors, you need to know this. Okay, because when you do calculus and you do integration, one of the methods is integration by partial fractions. So what we are going to do in this video, this is part 1, because we have to do several. Okay, we have to solve several problems on this so that you will have a better understanding about it. This should not make you to change your major. Okay, calculus should not. No, calculus should never make you to change your major. No. Okay, so what we're gonna do in this video, the examples we will do here are the same examples we will do when we do integration by partial fractions. So that way it's easier for me and for you. So it's better you learn this first. Then when we now come to integration by partial fractions, it will be much simpler for us. Okay, it will be much simpler for us. So the examples I'm gonna do here for this video and other parts, we are going to still do the same examples when we do integration by partial fractions. We are going to, it's not difficult at all. Okay, so just follow me. I will try to explain it well. And if you have any questions at any time, the best way for me to answer your questions is if you contact me through my website. If you post it as comment on YouTube, some YouTube comments I don't look at it. Some I look at it, some I probably will not. So it's when I have time. It's when I have time that I read comments and probably read the questions on YouTube, and if I can, I'll answer it. So please, if you ask a question on YouTube as a YouTube comment, if I do not answer it, that probably means I'm very busy or I probably did not look at it. For me to answer your questions, the best way is to contact me through my website. And I would answer your questions as time demands, okay? So I'm doing this video because I have a little time before the semester begins. So I have to, I want to see how much I can do. So please, if you have any question and you really want me to answer it, the best way is to contact me through my website. I have another website which will be on the video as well. You can contact me through any of those two websites. Partial fractions. So partial fractions is just, when let's come to arithmetic. Let's look at arithmetic. When you do something like 2/3 plus 5/8. Okay, when you do this 2/3 plus 5/8, you're adding these two fractions. So let's go ahead and add it. They don't have the same denominator. Okay, so we have to put them to have the same denominator. And the LCD of 3 and 8 is 24. 24. So what will you do to 3 to give you 24? You multiply by 8. Okay? Actually, if you want me to do it like this, because some people prefer it like this. So you have 2/3 plus 5/8. So the LCD is 24. What will you do to 3 to give you 24? Multiply by 8. Whatever you do to the denominator, you also do to the numerator. So this is 16 out of 24. This is the equivalent fraction of this. Equivalent fraction of this. And here, what will you do to 8 to give you 24? Multiply by 3. Whatever you do to the denominator, you also do to the numerator. And this will be 15 out of 24. So this is equivalent fraction. This is the equivalent fraction. This is the equivalent fraction of this. Okay, 15/24 is an equivalent fraction of 5 out of 8. So now they have the same denominator. You now get, because they have the same denominator, just bring the single denominator. And this is 16 plus 15, and that is 31/24. Okay? So you have this 31 out of 24. This is the whole fraction here. It is an improper fraction. It is an improper fraction because the numerator is greater than the denominator. So it is an improper fraction. Okay. This is an improper fraction because the numerator is greater than the denominator. And these two right here are the partial fractions. Two partial fractions. So I'm going to call this the whole fraction. I'm going to call this the whole fraction. Okay? That's what I will call it. Whole fraction. And these are the two partial fractions. Okay. It must not be only 2. It could be 3, it could be 4, it could be 5. And it must not be improper. The whole fraction must not be improper fraction. So let's look at another example. If I have maybe 1/2 plus 2/5, okay, plus 1/8. So you look at these three fractions, okay? So remember we have 1/2 plus 2/5 plus 1/8. So they don't have the same LCD, so let's get the LCD, a common denominator of 2, 5, and 8. 2, 5, and 8 would be 40. Okay, 2 times 5, 10 times 8, 80. But we can use 40. Okay, we can use 40. 40 is the lowest common denominator. Okay, because actually you have 2, you have 5 is 5, you have 8 to be 2 times 2 times 2. So this 2 and this 2, we can get them together. And we just have 2 times 2 times 2 times 5. And that gives us 40. Okay? We can get the 2 2's one time, and then we still multiply every other guy, every other person. So 40. So what will you do to 2 to give you 40? You multiply by 20 times 20. So this is 20 over 40. And this will be times 8 times 8. This is 16 out of 40. This is times 5 times 5. This is 5 out of 40. And that will give us 36. 20 plus 16 plus 5 over 40. That is 36 plus 5 over 40. And that's still 41 over 40. Well, this is still improper fraction. But you could still have, let's say we have 1 over 5. Let's say we have 1 over 5 instead of 2 over 5. I want to show you that the whole fraction can still be proper fraction. So let's say we have 1 over 5. This will be 8. So this will be 20 plus 8 plus 5. So 28 plus 5. And that is 33 over 40. Okay? That is 33 over 40. So this is 33 over 40. This is a proper fraction. This is the proper fraction. And it is also the whole, I call it the whole, for this video, I will just call it a whole fraction. Whole fraction. And these 3 here are the 3, these are 3 partial fractions. 3 partial fractions. So do you see that now? Okay, so what we say partial fractions is just those individual fractions that you add to give you that. And it must not be add, you could also subtract. Okay? Provided you could add or subtract to give you that whole fraction. It must not be only addition. It could also be subtraction. So what are we going to learn in this topic? In this video, we are going to be giving this whole fraction, and you now split it into partial fractions. Do you see that now? That is the idea of partial fractions. So Americans will say decompose into partial fractions. Nigerians will say resolve. Okay. Americans will say decompose. Decomposition of partial fractions. Decompose. Nigerians will say resolve into partial fractions. Resolve into partial fractions. It doesn't matter, provided the word term partial fractions is there. I would prefer to say split. Split into partial fractions. So I can use any of these words. When I say, just know I mean split the whole fraction into partial fractions. Okay. So how do I know whether I am correct? How do I know? Now, how will I know is because after splitting it into, I will be giving, usually they give you the whole fraction. Then you're required to decompose into partial fractions or resolve into partial fractions or split it into partial fractions. So how would you know that you're right? By checking it. So all you need to do is add up those partial fractions, add it up to see whether it will give you back the whole fraction. If it does not give you back the whole fraction, then you are incorrect. You made a mistake. Okay? If it gives you back the whole fraction, then you are correct. So We are going to take our, because I am a teacher who wants, I am strict about checking. I always require that my students check their work. It's very, very important. So some of the professors, some of mathematics professors do not ask you to check your work. Okay, that's fine. But I require my students to check their work. So I'm going to check for the questions we shall do in this video. I will check it. Okay, I'm going to check it to make sure that I got it right, because that's the way I would know how to get it right. Unless you want to use a calculator, you know, we have some partial fraction calculators, of which I'm also trying to develop. I have several calculators I have developed already, but I'm looking into developing a calculator also on this. But otherwise, it is highly recommended that you check your work by adding the partial fractions to see whether it gives you the whole fraction. Remember, the whole fraction could be improper fraction, or it could be the proper fraction. Okay? Could be improper fraction, or it could be proper fraction. Okay? So, we are going to now look at the forms of the whole fraction. So let's look at it. So remember, the partial fractions could be 2 or more. Okay? It could be 2 or more. Partial fraction is not going to be only one, because that's why you have partial fractions. It has to be 2 or more. Okay, so let's now look at the whole fractions, the forms of the whole fractions. Whole fractions. So remember that we said that the whole fractions could be proper fractions or improper fractions. So, and remember we said that the whole fractions could be proper fractions or improper fractions. Improper fractions. So we are now back to algebra, because what we just did was arithmetic. Excuse me. So with algebra, please, when you're checking your work, that means you need to know how to add and subtract rational functions. So if you go to my website under algebra, I have done videos on adding and subtracting rational fractions. Okay, adding and subtracting rational fractions. So now, how do you know? With arithmetic, if it's proper fraction, the numerator is less than the denominator. If it's improper fraction, the numerator is greater than the denominator. So when we have algebraic fractions, okay, the kind that you see x, y, p, okay, so how do you know whether it is proper fraction or improper fraction? Okay, you take this down. If the degree, okay, if the highest degree of the numerator is greater than the highest degree. Now, for the algebraic fractions, the first thing, please, you can take this down. You take it down. First thing you do is make sure you expand both the numerator and denominator as applicable. Like, make sure they are in the general form. What I mean by general form is in the descending order of exponents. in the descending order of exponents. Like, do not, when you're giving the algebraic fraction, like on your rough work, or by inspection, try to put it in general form first. Why are you doing that? Just to know the highest degree of the exponent. Okay, just to know the highest degree of the exponent. Try to like put it in the general form just to know the highest degree of the exponent. So we're going to look at examples here, so you kind of say it. If the highest degree of the numerator is less than the highest degree of the denominator, okay, when you put the denominator, like assuming it was in general form, that is descending order of exponents, then the fraction is a proper fraction. If the highest degree of the numerator is equal to or greater than the highest degree of the denominator, then the fraction is an improper fraction. Okay, I repeat. If the highest degree of the numerator is less than the highest degree of the denominator, then the fraction is a proper fraction. If the highest degree of the numerator is equal to or greater than, okay, is greater than or equal to the highest degree of the denominator, then the fraction is an improper fraction. Okay, forms of whole fractions. First of all, I'm going to deal with the proper fractions, okay? Then we now go to improper fractions. So I'm going to deal with proper fractions first. Proper fractions. Okay. First form or first case. Okay? Let's look at first form. Or you can say first case. First case. Remember, I'm dealing with proper fractions. First form of first case is linear factors. Unrepeated linear factors. Or let's say here, unrepeated linear factors. First form. For proper fraction, we're still in proper fraction. Unrepeated linear factors at the denominator. Unrepeated linear factors at the denominator. Let me write it under here, so I will have space. Under proper fractions, first form or first case is unrepeated linear factors at the denominator. At the denominator. Unrepeated linear factors at the denominator. Okay? That's the first case. Okay, now let's look at this for a moment. We could have number one, if we have x minus 1 over x plus 3, 2x minus 7. So you look at this is a proper fraction. It's a proper fraction. Why? The highest degree of the numerator is 1. Then look at the denominator. The denominator is 2 linear factors. 2 linear factors. That's the denominator. 2 linear factors. Okay? But the highest degree, if you were to put that in standard form, you see what I said about standard form? Because first of all, you want to make sure, you want to know whether it is a proper fraction or an improper fraction. If the whole fraction is a proper fraction or an improper fraction, that is the first thing you have to check. Okay? Now, sometimes they will not put factors at the denominator. You will have to do it yourself. I'm going to show you. So, the first thing you look at this is find out whether it is a proper fraction, whether the whole fraction is a proper fraction or an improper fraction. If it's a proper fraction, then look at the factors at the denominator. If they are linear factors, okay, just you see you have two linear factors there. Good. So this is the way you do it. You now say that when you're splitting it into partial fractions, this will be a over x plus 3 plus b over 2x minus 7. That's it. That's it. That's the first thing you do first, to split it into linear, to split it into partial fractions. Okay, now let's look at this again. We can have this like this, x minus 1 over, now this is 2x squared minus 7x, because they must not give it to you like this. They must not. They could give it to you like this. This is 2x squared minus 7x plus 6x minus 21. So this is 2x squared minus x minus 21. Okay? 2x squared minus 7x plus 6x minus 21. So they must not give it to you, they must not give it to you like this. No, they must not. No. They must not give it to you like this. They can give it to you like this. And if they give it to you like this, then it is you who would now have to factor the denominator. You have to factor the denominator. So you just say this is x minus 1 over 2x squared minus x minus 21 equal to, you now, you split this, you factor it first. X plus 3, 2x minus 7. So this is a over x plus 3 plus b over 2x minus 7. We don't care about the numerator, okay? So forget about the numerator for now. The main thing the numerator is important is knowing whether it is a proper fraction or improper fraction. That is the main thing about the numerator. Otherwise, once you figure out, oh, it's a proper fraction, just check the denominator and see what it could be. Okay? And you remember, these are unrepeated linear factors at the denominator. Okay? So they must not, they can give it to you like this or they can give it to you like this. And you put it this way. Okay? Now, the next one, let's keep on. I'll show you more examples. I'm going to show you more examples of this. Number 3, you could have 7 over x times 2x minus 1 times 3x plus 2. These are still unrepeated linear factors at the denominator. They're still unrepeated linear factors at the denominator. The numerator is 7. Okay, because that means x0. This means x to the 0. Okay, exponent 0. Remember, anything exponent 0 is 1. So this is like saying x to the 0 plus 7. That's it. Okay, so it is still, the highest exponent of the numerator is 0. That's fine. And the highest exponent of the denominator is 3. Okay, because when you put this in standard form, when you put it in general form, when you put that in general form, you know, in descending order of exponents, of course you have x times 2x, 2x squared times 3x, 6x cubed. So the highest exponent is 3. So the numerator is just there to kind of tell us, is it a proper or improper fraction? Remember, we are still working on proper fractions. Okay? So if it is a proper fraction, then go ahead and now check the denominator. Now remember, they must not always give it to you, the denominator, in factored form. No, they must not. They can expand it and give it to you in general form, or even they can give it to you in general in a form whereby it is not factored and they rearrange it. Okay, it is up to you to now factor it and then resolve it or split it into partial fractions. So you look at this now, we have three linear factors at the denominator, unrepeated linear factors. So this will give us a over x plus b over 2x minus 1 plus c over 3x plus 2. That's it. This will be three partial fractions. Okay? Another one, we could have 6 minus 2p. 6 minus 2p over p plus 1, p minus 1. You could have this p squared. Let's put this as this. 9p squared minus 16. Okay, you might ask me, hey, Mr. C, I was thinking you said unrepeated linear, not quadratic. But now I say quadratic. Well, you have to do it. It's linear. So factoring, I did a whole video on factoring, on algebra. You need to know all forms of factoring. So this is what we call difference of two squares. So you have to resolve it, you have to always factor the denominator. So this is still under this case. It's still under this case. Because this is 6 minus 2p over 3 squared p squared minus 4 squared. So this is 6 minus 2p over 3p all squared minus 4 squared. Okay? And this is still proper fraction. So this will be 6 minus 2p over 3p plus 4 times 3p minus 4. So they must not always give you bread and tea, or tea and coffee, or tea and egg. Like, they must not. They can give it to you like this and do. Okay. It's not easy. You are taking calculus, you have to be strong. Okay? So now these are now linear factors. And this is now a over 3p plus 4 plus b over 3p minus 4. Okay? Let's do another one, and then we go to the next form or the next case. You might have 3k all over k minus 1, 2 minus k, 4 plus k, k minus 5. Again, this is a proper fraction. Okay. So what do you think this will be? We have 4 linear factors at the denominator. And then what's the highest exponent? What's the highest exponent of k in that denominator? It is 4. Okay, it's 4. And you see it's not well arranged, but that's fine. Okay. So, and the highest exponent of the numerator in this case is 1. Okay. When I say highest exponent, I mean highest exponent of the variable. of the variable. I'm talking about the variable. Okay. So this will be a over k minus 1 plus b over 2 minus k plus c over 4 plus k plus d over k minus 5. So you have 4 partial fractions there for that case. So for each linear factor, you have just one constant, one variable there. Okay, and these are still constants. So for each linear factor, you have one constant there. These are A, B, C, D are all constants. I know I used letters, but in this case, they are all constants. So for each linear factor at the denominator, you have one constant on top. Just know that. Okay, if it is not, that's for each linear factor at the denominator, you must have one constant on top. Now for each quadratic factor at the denominator, because that's the next thing we'll go. For each quadratic factor at the denominator, you will have 2 constants there. Okay, we'll look at that. But at least I hope you understood unrepeated linear factors at the denominator. Okay? Now, let's look at unrepeated unrepeated linear and non-linear factors at the denominator. Okay, because I want you to be able to know all the cases. Okay, so the next thing I'm going to do here is, well, let me do unrepeated non-linear factors at the denominator, and then the next form will be mixture, still unrepeated. Then we can now go to repeated. Okay, so second case, I'm going to put this second case or second form. This will be unrepeated non-linear. Second case, second form or second case, we have unrepeated non-linear factors at the denominator. Okay, so we could have 3 minus 2x all over x squared plus 7 times x squared minus I want the one that could not be factored. The one that cannot be factored, s squared. Let me probably look at some examples here, because I want something that you cannot factor, so that way yeah, we can factor x squared minus x plus 1. Yeah, look at this one here. Yeah, you can factor this. Okay, so you look at these two factors. You cannot factor them. You cannot. So what I mean non-linear factors, it is when you at the denominator. It means when you cannot factor them. If you can factor them, you got to factor them. If you can factor the denominator, you must have to factor it. Must. If you cannot factor it, that is what I mean. So you look at this now, you cannot factor this. You cannot. And you cannot factor this. Okay, you cannot factor this. So this will be, and you know that this is still a proper fraction. Okay, the highest exponent of the variable, the degree. Okay, when I say highest exponent, I mean degree. The degree of the numerator is 1. Okay, because this is x to the 1. That's the degree of the numerator. And then the degree of the denominator is 4. The degree is the highest exponent of the variable in the numerator or the denominator. So this will be, now, for a quadratic that cannot be factored, this will be ax plus b over x squared plus 7. Ax plus b over x squared plus 7 plus cx plus d over x squared minus x plus 1. Do you see that? For a quadratic, it has to have two constants at the numerator when you're resolving it, when you're splitting it into partial fractions for a quadratic. Okay, see that? Another example, I can have 4 all over 5 minus 2p cubed then I have 3p squared minus p minus 2p plus 7. Okay? You look at this one now, you cannot factor it. You cannot factor it. No, you cannot. If you can factor it, you must factor it. Okay? But you look at this one, you cannot factor it. 7 times 3, 21. It's just 3 and 7 won't work. And 1 and 21 will not work. 3 and 7 will not work. Okay, so you cannot factor it. You've got to make sure you cannot factor it before you resolve it into partial fractions. So in this case, of course, the degree of the numerator is 0. The degree of the numerator here is 0. Because this is like saying 4 plus b to the 0 power. Okay? The degree is the highest exponent of the variable. Okay? So the degree of the numerator is 0. The degree of the denominator is 5. The degree of the denominator is 5. Okay, 3 plus 2 is 5. Okay? So, you now resolve this for a cubic. For a cubic, when you resolve it into partial fractions, then you have to have a quadratic on the numerator. You see, for a quadratic, you will have a linear. For a linear at the denominator, you just have a constant. Okay, just a constant. But for a quadratic at the denominator, make sure you cannot factor it. Okay, for a quadratic at the denominator, you have a linear factor with 2 constants there at the numerator. For a cubic, you will have a quadratic. You have a quadratic. So this will be ax squared plus bx plus c all over the cubic 5 minus 2p cubed, okay, plus this is now a quadratic. So it will be dx plus e over 3p squared minus 2p plus 7. That is that. That's how you resolve it. Because this is cubic, you now have that. Okay? Comprende? Comprenez-vous? Una otra raya? Comprende? Comprenez-vous? Do you understand? Do you understand? Non-linear factors at the denominator. Okay? Let's do another one. We could have 4x squared minus 3x plus 10 all over 3x4 minus 5 3x4 minus 5 4 minus minus 7x cubed. 4 minus 7x cubed. Okay? Now look at this one here. You cannot factor it. Okay, I'm making sure I don't put the ones you can factor, no? Okay. So because if you can factor it, you must factor it. And when we come to the third form, whereby we mix it up, then we can, well, we look at the repeated, and then we now look at whereby you can mix it up. Okay, now look at this here. You look at this right here. You cannot factor the denominator. The degree of the numerator is 2. The degree of the denominator is 7. Okay, the degree of the denominator is 7. So, it is a proper fraction. It is a proper fraction. Now, you now ask yourself, how do you, it's a proper fraction, so you now forget about the numerator, because the numerator just tells you now it's a proper fraction. Now we now look at the denominator. We have a quartic factor and a cubic factor. A quartic and a cubic. So when you're resolving this with quartic, when you're resolving it, the numerator is going to be a cubic. It's going to be a cubic. So this will be ax cubed plus bx squared. You have to make it a complete cubic. Plus cx plus d. All over 3x4 minus 5. Then plus ex squared plus fx efg plus ex squared plus fx plus g over 4 minus 7x cubed. That's it. That's how you resolve it into partial fractions. Okay? So at least you have that idea. Okay, you now have that idea. Alright. We're going to go to the third form. The third form, we're going to look at repeated linear. Okay? We look at repeated linear. Then we look at repeated nonlinear. Then we look at mix-up. Mix-up of both linear and nonlinear. Unrepeated. Then we look at mix-up, linear and nonlinear repeated. Then we go to improper fractions. Then we shall try to solve at least a question here, at least a question or 2 questions here, before we can call it a night, okay? So I'm trying to make sure you get this, you understand it first here. You know, you have a good understanding on this first, before we now solve questions. Okay, so the third form or third case. Okay, third form or third case. Third form or third case. We have repeated linear factors at the denominator. Repeated linear. Okay? So, we can have 3x minus 3x, negative 3x over x squared times x plus 4 all squared. Or let me just let's do it step by step, okay? X plus 4 all squared. Okay. Even if you have this, you know, you have this. This is a repeated linear. It's a repeated linear. And they must not, even if they don't put it like this. Okay, even if they don't put it like this, they can still put minus 3x over x plus 4 times x plus 4. Minus 3x over x plus 4 times x plus 4. When you have it this way, please, 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 do not, I repeat, do not do a over x plus 4 plus b over x plus 4. No, you don't do that. No. You don't do that. So when you have it this way, it is still like this. Minus 3x over x plus 4 all squared. You must have to recognize that it is repeated. Take note of that. Okay? Take note of that. So this here, is it a proper fraction? Yes. What is the degree of the numerator? 1. What is the degree of the denominator? 2. So it is a proper fraction. Remember, the degree of the numerator should be less than the degree of the denominator. Okay? So this will be, this is linear, so only one constant at the numerator. A over x plus 4 plus b over x plus 4 all squared. That is the way we do repeated. So you have to put it with like this, then the other one like that. That's the way you do that. Okay? So this is the same thing here. A over x plus 4 plus b over x plus 4 all squared. Do not forget this, because if you remove this, it's wrong. You have to recognize the fact that it is repeated. You have to. Okay, let's do more examples. Let us do more examples. Seven minus 2k all over k squared times 2k minus 3 all squared. Okay? So, what is the degree of the numerator? 1. What is the degree of the denominator? 4. If you had to put this in standard form, if you had to put the denominator in general form, it is 4. The degree of the denominator. That is the highest exponent of k, highest exponent of the variable k. So, this is repeated. It's a linear factor. The linear factor is k, but it's repeated. Okay? So this will be a over k plus b over k squared plus c over 2k minus 3 plus d over 2k minus 3 all squared. Be careful. See that? Okay? Remember, once we see the fact that it is proper fraction, just go ahead and resolve it, the numerator. Because I want you to understand, go ahead and resolve it, because the numerator is of no use anymore. Okay, later the numerator will be of use when we begin to solve it. Then, once you determine it's a proper fraction, just now look at the denominator and split it. Okay. Now, another one, we could have 12 over x cubed times 2 minus 3x all cubed. Okay? This is just to give you an idea. Okay, at least Give you an idea so you will know how to resolve, how to split it. So what is the degree of the numerator? 0. What is the degree of the denominator? 6. Okay. So this will give us a over x plus b over x squared plus c over x cubed plus b over 2 minus 3x plus e over 2 minus 3x all squared plus f over 2 minus 3x all cubed. Does that make sense? That is how you do it. Okay. Now, these are still linear. So don't come here and put bx plus c. No, please. Do not come out here and put bx plus c. No. Because it's still linear. It's still linear. It's just repeated. It's linear, but it's repeated. So please don't put bx plus c. No. Okay. Excuse me. The next one, fourth form or fourth case. We'll do repeated non-linear factors at the denominator. The fourth form or fourth case, repeated non-linear factors. So when you see just x squared, it means it's repeated, x times x. But you have to make sure you do a over x plus b over x squared. And for all repeated, remember, the numerator is just a constant. Okay, fourth form or fourth case. Repeated non-linear factors at the denominator. Remember, it is non-linear factors when you cannot factor the denominator. Okay, that's when you make sure if you can factor the denominator, you have to factor it. If you cannot factor it, then no. Okay, then it's non-linear, provided you cannot factor the denominator. So maybe let's have 3 minus 2x plus 7x squared all over x squared minus 5x. Let me call this 7x squared minus 5x minus 11. 7 is 7. 7 is 7. 1 and 7 is 7. No. 7 and 11. No. Yeah, no. So this cannot be factored. And I call this squared. Okay, let me start with this here. This is still proper fraction. What is the degree of the numerator? 2. What is the degree of the denominator? 4. So it's still a proper fraction. Okay? So this will be ax plus b over 7x squared minus 5x minus 11 plus cx plus d over 7x squared minus 5x minus 11 all squared. When you're doing repeated, you've got to do it one at a time. And that when you're doing repeated. Comprende? Comprenez-vous? Okay, let's look at another one. 5p squared plus 7 all over 3p squared plus 7 all cubed and 2p cubed minus 5 all squared. Okay. Look at this here. This is still a proper fraction. Okay. What is the degree of the numerator? 2. What is the degree of the denominator? Here, 2 times 3 is 6. 3 times 2 is 6. 6 plus 6, 12. 12. Okay, 12. The degree of the denominator is 12. So, how do you think you're going to do this? Okay, the same way, you just have to be careful. Actually, I will have more space. I need more space. But this is just for you to have that idea. Okay, at least for you to have the idea of how to do it. So try to resolve this. It's still a partial fraction. So how do we, it's still a proper fraction. It's a proper fraction. Okay, so how do we go about this? This will be ax plus b over the quadratic 3b squared plus 7 plus cx plus d over 3p squared plus 7 all squared plus ex plus f over 3p squared plus 7 all cubed. Okay, we're done with that. We're done with this one. Plus EFG. G x squared plus hx GHI plus I over 2p cubed minus 5. Okay, plus ij. Jx squared ijk plus kx ijkl plus L over 2p cubed minus 5 all squared. That is it. That's a big punishment to give somebody this kind of thing. Right? Okay, but at least you have the idea of what I'm talking about, right? Okay, now the next one we'll do under proper fractions before we go into improper fraction will be mixture. Okay, mixture, the fifth form or the fifth case. Mixture of both repeated, unrepeated, and repeated linear and non-linear factors at the denominator. Let's just see how it will work. Okay, because at least these are the basic 4 forms for proper fractions. Now the next one you should now, I expect you to now kind of like know which one. So we're gonna look at some of these here, so we can just, the ones that are not, the ones that are proper fraction, and that way you can now, you know, at least I expect you to now have the idea. Please, when you're viewing my videos, when you pause, you try to do it on your own, then you play to see whether we get the same thing. Okay? It should be interactive. So fifth form is all under still proper fraction, mixed, yeah, like both repeated and unrepeated, linear and non-linear factors. So fifth form is everything. Fifth form or fifth case. Let's now look at several cases. Several cases. So fifth form, I will expect you to at least So at least get these right. Okay? Repeated and unrepeated. Repeated or unrepeated. Unrepeated. Linear and nonlinear. And nonlinear factors. Repeated and unrepeated, linear and nonlinear factors are the denominator. Factors are the denominator. At the denominator. Okay? Alright folks, let's remember, whatever we have to check whether we can factor the denominator. Okay? And I'm going to just look at partial fractions. I'm just going to look at partial fractions. That's what I'm going to look at. Proper fractions. I'm going to look at proper fractions. Okay. Number 1, 89 over x squared minus 6x. 89 over x squared minus 6x. Okay, please, you can factor the denominator. You must do it. That's the first thing you look at. Make sure it's proper fraction and then look at the denominator. If you can factor it, factor it. Okay? I did a whole video on several types of factoring. We have factoring by GCF, factoring by grouping, factor by GCF, factor by grouping, factor by difference of two squares, factor by difference of two cubes, factor by sum of two cubes, factor by factoring quadratic trinomials, factoring quartic trinomials. Okay, you've got to know all these forms of factoring. You've got to. Okay, so we look at this now. What is the degree of the numerator? Is 0. What is the degree of the denominator? It is 2. Okay, that's the degree. But then look at the denominator. It is not quadratic. No. If you can factor it, you factor it. So this is, we can factor by GCF. So this is 89 over x minus 6. So these are two linear factors. A over x plus b over x minus 6. That's it. Okay? Number 2, and this is not repeated, no. 1 over x squared minus 81. Yeah, we've done that particular one, that's fine. The next one is this, x squared plus 108x plus 108. 108x plus 108 over x cubed minus 4x. X cubed minus 4x. Okay. What is the degree of the numerator? 2. What is the degree of the denominator? 3. So it is a proper fraction. It is a proper whole fraction. Look at the denominator. Can you factor it? Yes. So we factor by GCF. So this will give us x squared plus 108x plus 108 all over x squared minus 4. Have to be careful. Then we find out that we can still factor more. You see that? We find out that with that denominator we can still factor more. Okay? Now this is still a proper fraction. Remember, with proper fraction we are just looking at the degree of the numerator and that of the denominator. Not when it is in factored form. No. We just want to get that degree. Okay, that's why I said expanded. That's why I said already it's expanded, but After we now know that it is proper fraction, then we have to factor the denominator. We could still do this one. We still find out that this here is x squared plus 108x plus 108 over x squared minus 2 squared. So this is x squared plus 108x plus 108 all over x plus 2 times x minus 2. Right? Okay. So we now have 3 linear factors at the denominator. Unrepeated linear. Okay. So this is a over x plus b over x plus 2 plus c over x minus 2. You got to look at that. Factoring the denominator. Okay. Number 3. This one will give us improper. We have this one, 11x squared plus 2x minus 8 plus 2x minus 8 over x cubed plus x squared, x cubed plus x squared. Okay? What is the degree of the numerator? 2. What is the degree of the denominator? 3. Okay? So it is a proper fraction. Now we have to look at the denominator. We have to factor it by GCF. So this is 11x squared plus 2x minus 8 over x squared is the GCF, x plus 1. See that? X squared times x plus 1. So we have a repeated linear factor and another unrepeated linear factor. We have the linear factors here. We have a repeated linear factor, which is x, and then an unrepeated linear factor, which is x plus 1. So this will give us a over x plus b over x squared plus c over x plus 1. Okay? Number 4. So you see, this is for you to at least know what to do. For you to at least know what to do. Okay? Number 4, we have this one. X squared plus 5. X squared plus 5 over x times x squared plus 1. X times x squared plus 1. Okay, look at this. An example. So this, what is the degree of the numerator? 2. What is the degree of the denominator? 3. Okay, so this is a proper fraction. So this is a over x plus bx plus c over x squared plus 1. That's it. Okay. So at least you have an idea for proper fractions how it should be. You have that idea. Okay. So we're gonna get to improper fractions, and we will solve at least one question. I want us to solve at least one question on this part 1, and then the next time we're gonna just solve more problems. Okay, because the next time when I go ahead and resolve it, at least you know what I'm doing. Okay, so at least this here, you at least know how to resolve any one, and then and then we do at least one problem here, okay? And then the part 2 will now solve more problems. And we'll probably get into part 3 because I really want us to solve all the problems I want us to solve, all the problems I would like to solve in this video are the same problems we will solve in integration by partial fractions. Already we now know our answers. Okay, so when we do integration by partial fractions, it will be much more easier for us. Okay. Let's look at improper fractions. That's the sixth form, improper fractions. So the sixth form is just improper fractions. I just call it sixth case or sixth form. Will be improper fractions. So sixth case, improper fractions. So with improper fractions, I will dictate and you just write. The degree, excuse me, the degree of the numerator is greater than or equal to the degree of the denominator. That is with improper fraction. So you make sure you have found the degree of the numerator after you, assuming they gave it to you in factored form or general form or whatever form. Just find the degree, get the general form, find the degree, highest exponent of the variable in the numerator. The same thing you do to the denominator. Whatever form they give to you, make sure you put it in general form just to find the degree. If the degree of the numerator is greater than or equal to the degree of the denominator, it is an improper fraction. So what do you do with improper fractions? You first of all do long division of polynomials. So if you don't know how to do long division, go to my website. Under algebra, you will see division of polynomials and look for how to do long division. Very important. So I'm going to give you examples of improper fraction. We'll still solve it later on, but not in this video. But I'll show you the examples. So the first thing you do, if you notice it is an improper fraction, first of all, use long division to find the quotient and the remainder. So you put it in another form, and then you now resolve it. Because remember, with improper fraction, you have a quotient and then proper fraction. Just like if you come to arithmetic, when you do arithmetic, you do maybe 7/2. So this is an improper fraction. Okay. So this means 3 whole number 1/2. Okay. So it gives you a whole number and a proper fraction. That is what it gives you. So the quotient is 3 and the remainder is 1. So with improper fractions, you first of all do a long division. Then you have a quotient. Okay, you have a quotient which you shall keep plus the remainder over the divisor. Okay, this is the dividend, this is the divisor. This is the quotient, this is the remainder, this is the divisor. So view my videos on polynomials by long division. With improper fraction, you have to do long division first. Then it gives you a whole number and a proper fraction. And then you now resolve that proper fraction. See, you now resolve that proper fraction into partial fractions. So with improper fraction is just a little more work, you know, but use a quotient and a proper fraction. Then you now resolve that proper fraction. Then you now integrate. When we do integration by partial fractions, you integrate both the quotient and the partial fractions. That's with integration by partial fractions. Okay, so let me just give you just one or two examples of improper fractions. You look at this one here, 2x cubed, integral of 2x cubed minus 8x squared minus 63x plus 46 all over x squared minus 4x minus 32. X squared minus 4x minus 32. Oh, I forgot I wasn't teaching calculus. What? Okay, this is integration. I'm still teaching algebra. Okay, so please don't be scared of this. Let me remove it. Integral sign. But this is integration of integral. This is integration by partial fractions. So this is an improper fraction. Okay, that's the integral sign. Because some of you probably might not do calculus, but like some people in Nigeria, they do further mathematics, but they don't go into engineering. So even in further mathematics, yeah, you still do calculus. So you still do it. You shouldn't be scared if I put it. Okay? This is integration by partial fractions, but this is improper fraction. Because the degree of the numerator is 3, the degree of the denominator is 2. So it's improper fraction. Okay? We still have another one. We still have some more here. But you know, that's just that is it. So just review the video I did on long division, okay, and we will do this when we do problems. So for now, let us do just one question. I'm gonna do one question because of time, and then we'll call it a night. Now remember, whatever question I do here is the same question I will do in integration by partial fractions. So I will have to number it. I will number it. Okay, I'm gonna number it. So we'll know whatever question I do here and the other parts is the same question I'll do integration by partial fraction. So so that way I'm not, when I do integration by partial fraction, then I will not come and start doing the whole we've already resolved it, so we'll just go straight to the integration by partial fractions. Okay. So this is the first question I see here. Question number 1, integral of 1 over x squared minus 81 dx. Okay. I'm not going to do the integral right now, no. Okay, I'm just interested in just the partial fractions only. So this is 1 over x squared minus 81 is 1 over x squared minus 9 squared. Okay, which is 1 over x plus 9 times x minus 9. Okay, which is a over x plus 9 plus b over x minus 9. Right? Okay, I will solve and check. Solve and check. That's what I'm going to do. Solve and check. Please take note of whatever, in fact, whatever answers we get, I will write it down. So when we do integration by partial fractions, we will not come and start solving this again. We'll just go straight to integration. Okay. So this is our main thing right now. This here is what we're going to look at right now. I'm going to use a yellow chalk. That's what we're going to look at now. So let's go ahead and solve it. LCD, we want to, LCD is x plus 9 times x minus 9. So you write, multiply everybody by the LCD. We don't like fractions, right? Okay, if you don't like fractions, that's fine. We don't like fractions, so multiply everybody by the LCD. Now, let me go ahead. I'm going to go ahead and write 0x plus 1. And you will still realize why I wrote 0x plus 1. Okay, I need it because later on you will realize, it's still 0x plus 1 anyway, but as we go on, you will realize why I wrote that. So multiply everybody by the LCD because we don't like fractions, right? Okay, or because we still like fractions, but we want to make it easier for us. So this means x plus 9 times x minus 9 times 0x plus 1 over x plus 9 times x minus 9. I'm showing all my work here, okay? But please do not be mad at me. I read, there was a comment I read on YouTube, and the student said that I teach well, but that I'm slow. The student said, you explain it well, but you're slow. Can you be fast? Okay, so, you can't satisfy everybody. Like, when I teach my videos on YouTube, I teach it as if I'm teaching it from scratch. So, I can solve it without having to do this. I can solve this right away. God blessed me with mathematics. I don't struggle with it. In my family, we don't struggle with mathematics. So we thank God for that. Okay, it's a talent from God, from Almighty God. So I can easily solve this right away. But then there are some people who take the time to look for the videos on YouTube because they did not understand it in classroom. And that is why I'm doing it. I'm also doing it for my students who missed class. I teach several students all over the world. So some students miss class. Some students I teach online. So they can go back and look at my videos and then make sense with it. So please, comments, it doesn't bother me anyway. But that is what, so please don't be mad if I'm breaking it down. I'm doing it for that other guy, okay? I know some of you will look at it. Why don't you just go ahead and multiply it right away? So please, I'm just doing it for that other person, okay? So we now multiply everybody. We multiply all terms, both sides, by the LCD. So x plus 9 times x minus 9 times a over x plus 9, then plus x plus 9 times x minus 9. I need to extend this. X plus 9 times x minus 9 times b over x minus 9. Okay? Alright? So then I go ahead and cancel it. Bam, 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 bam. So I have 0x plus 1 is a times x minus 9 plus b times x plus 9. No more fractions, folks. No more fractions. So I gotta find A, I gotta find B. Okay? So 0x plus 1 is ax minus 9a plus bx plus 9b. Right? So 0x plus 1 is, I get all the x together, ax plus bx minus 9a plus 9b. Do you see what I'm doing? Okay? So 0x plus 1 equal to x, a plus b, minus 9a plus 9b. So do you now see why I needed to put 0x? Do you see why I needed to put 0x? See that? See why I needed to put 0x. So 0 is equal to a plus b. And then 1 is equal to minus 9a plus 9b. Do you now see? So you just get the coefficients, the coefficient of x. 0 is equal to a plus b, and then the constant 1 is minus 9a plus 9b. Excuse me. Okay, so we can, let's write it well. Let's write this well. This means that a plus b is 0, and then minus 9a plus 9b is 1. You can multiply this by 9. Multiply this by 9, okay? I believe you know how to do this by now, okay? Multiply this by 9, you have 9a plus 9b equal to 0. If you don't, by now I expect you to know how to solve linear systems. This is a 2 by 2 linear systems. 2 by 2 linear system, 2 variables in 2 equations. So if you don't know linear system, to solve linear system, I have a whole under finite math, linear systems, how to, the whole thing about linear systems. That is a requirement. So you see, there are several requirements for this topic. Okay, so I just multiply this by 9 to give me this, and this is minus 9a plus 9b equal to 1. Okay, because whatever I've taught before, I expect you to know it, so I will just move on. So if we add this, assuming we add this, we have 18b to be 1. So b is 1 over 18. b will be 1 over 18. Right? b will be 1 over 18. Now what if we subtract it? Assuming we subtract it, if we subtract it, then we will have 18a equal to minus 1. Right? If we add it, 9a plus minus 9a, that's gone. 9b plus 9b is 18b. Okay? If we subtract it, it will be 18a equal to 0 minus 1, minus 1. So a will be minus 1 over 18. Okay? So we now have that. We now have that. We now have that 1 over x squared minus 81 is minus 1 over 18 x plus 9 plus 1 over 18 x minus 9. So we don't like minus to be in front. We don't like minus to be in front. So we just write 1 over 18 times x minus 9 minus 1 over 18 times x plus 9. Okay? And this is our answer here. That's our answer here. That's our answer. Those are the partial fractions. I mean, some people will factor out 1 over 18. Some people will factor out 1 over 18 and then write it as 1 over x minus 9 minus 1 over x plus 9. Okay, but for now, I just want us to write it this way. Okay, because in the partial fractions, So these are the two partial fractions that give us this compound fraction. Okay. Now, Mr. C would like you to do what? Mr. C would like you to do what? What? Check your work. Check your work. Okay, I would like you to check your work. So let's go ahead and add those two partial fractions and see what it gives us. So the two partial fractions, 1 over 18 x minus 9 minus 1 over 18 x plus 9. So when we do this, what's the LCD? 18 times x minus 9 x plus 9. This is the LCD. If you want to solve your fractions step by step, that's fine. Do we need to solve it step by? Okay, let me solve it particle form. Let me just solve it particle form. That's fine. Because some people understand particle form more. X plus 9. Okay, so LCD is 18 x plus 9 x minus 9. That's the LCD. 18 x plus 9 x minus 9. Okay. So what will you do to this to give you this? You multiply by x plus 9. Okay. Multiply by x plus 9. Whatever you do to the denominator, you do to the numerator. X plus 9. Right? So this gives us 1 times x plus 9. Right? What will you do to this to give you this? You multiply by x minus 9. Whatever you do to the denominator, you do to the numerator. Okay? So this is 1 times x minus 9. So now you can get everybody in the same denominator. 18 x plus 9 x minus 9. And this will give us 1 times x plus 9 minus 1 times x minus 9. And that gives us x plus 9 minus x plus 9 over 18 x plus 9 times x minus 9. Okay, and that gives us x minus x. X minus x is gone, right? 9 plus 9 is what? 18. 18 over 18 times x squared minus 81. Okay? Because you multiply, this is difference of two squares. That's the difference of two squares. So you do the two binomials, or you multiply the two binomials, or you just do difference of two squares. So 18 cancel 18 is 1. So this is 1 over x squared minus 81. That gives you back the whole fraction. Okay, that means you got it right. Okay, you've got to always make sure you check to make sure you actually did it right. Okay? Please, we will stop here for tonight. Go ahead and write this. So this is 1 over 18. So when we are doing the integral,